welcome to this explainer. Look, we're finally moving past the days of manually typing single prompts into a chat box and just, hoping for the best. Today, we're entering a totally different world, a world where we engineer automated systems. We're diving deep into loop engineering. If you want to understand how serious professionals are actually getting work done with AI right now, you are in the exact right place. Let's get into it. So here's our roadmap for today. We'll go from prompter to loop designer, break down the anatomy of a loop, look at building your first loop, figure out avoiding common loop traps, and finally we'll talk about your ultimate edge, taste. Okay, section 1. From prompter to loop designer, the paradigm shift. To really get this shift, we gotta rewind just a bit to the second week of June 2026. That's when this whole concept of loop engineering just caught fire. It was named in an essay by Adi Osmani and really popularized by the creator of Claude Code. And it fundamentally reorganized how pros work with AI because it challenges our basic day-to-day behavior. The core idea, the unit of work is absolutely no longer a prompt you type. It's a loop you engineer. Think about it. For years, working with AI literally meant typing a prompt, reading the answer, and typing again. You were the loop. But as these coding and knowledge agents got super reliable at long tasks, the human in the middle, us, became the slow part. If you're still just typing in a box and waiting, you are the bottleneck. So how exactly did we get here? AI interaction actually moved in some pretty clear stages. Back in 2023, the hot skill was prompt engineering, right? Just phrasing one request well. Then in 2024, it shifted to orchestration, chaining a few steps together. By 2025, it was all about context engineering, really controlling exactly what the model sees. And then, in 2026, it evolved into loop engineering. Notice how each era didn't just replace the last one, it stacked right on top of it. Today, the real scarce skill is designing the system that drives the model without you. To really wrap our heads around this, we have to contrast a rigid, fragile chain with a dynamic loop. A chain is a fixed sequence. Do step 1, then 2, then 3. But here's the catch. It only works when you know every single step in advance. A loop, though, is entirely different. It tries something, observes what happened, and then decides what to do next based on that actual result. A chain absolutely cannot fix a failing test or adapt on the fly. A loop can. And honestly, that is what makes real progress. This brings us to the core rhythm of an agent loop, which actually pulls from a research lineage going back to the React framework in 2022. It's a remarkably simple 3-beat rhythm. First, the machine thinks and reasons about what to do. Next, it acts by doing something with a tool. Then it observes the result. And finally, it repeats. Think, do, look, repeat. That's the heartbeat of the whole system.
Moving on to section 2, anatomy of a loop, designing the machine.
So, getting past the theory here, we need to mechanically deconstruct the loop. Because a loop isn't just running a model over and over again. It needs a very specific structure. Otherwise, it breaks in ways you won't even understand. The absolute most critical step, and honestly where almost everyone fails, is defining what finished looks like in a way a machine can easily check. You just can't use vague instructions like, make it good. No way. A loop needs measurable terms. Things like all tests pass, or the output matches the schema, or no item on the checklist is unchecked. A loop without a crystal clear definition of done is a loop that never, ever stops. And that leads us right to this. You absolutely must build a strict external verifier. This verifier is the automated check that decides if the output actually meets your BOR. The biggest trap everyone falls into, letting the AI model grade its own homework. I mean, if you ask the model if it did a good job, it almost always gives itself an A, right? So the stricter and more external your verifier is, the better your loop is going to function.
Now, to prevent a runaway tool that just completely drains your budget or spins forever in circles, you have to stack specific termination logic exits together. It's like building safety valves. You need a verifier that confirms the goal is met, sure, but you also need a hard cap on iterations, so it can't run infinitely. You need a token or time budget limit, and crucially, a no progress detection that breaks the loop if recent steps just stop changing anything. Listen, any one of these alone, just not enough. You need the whole stack. And this builds into our final anatomical pieces, the state layer and the human checkpoint. Adding persistent memory, like saving to files or a task list, means your loop can survive crashes and pick up right where it left off instead of starting from scratch. And this is vital. You must place a human checkpoint before any irreversible actions. The loop can draft and verify all day long, but sending a message, deploying code, or spending actual money, that should always pause and wait for you. All right, Section 3, building your first loop, the worked example. Let's bring all this theory to life and apply it to a concrete, real-world scenario. Say you maintain a small code base and you are just so tired of manually fixing tests that break every time you change something. Building your loop for this takes a 5-step phase. First, pick a repetitive task with a checkable output. Second, do it manually first to learn the exact failure modes and figure out what done actually means in practice. Next, write the loop contract, setting your goals and checks. Then run the loop closed and watch every iteration to see where it messes up. And finally, continually tighten your verifier until the loop's standard of passing perfectly matches your standard. Sticking with our coding example, fixing broken code tests gives you a super simple definition of done. In fact, your verifier already exists. It's the test command itself. It either exits clean or it reports failures. There is absolutely nothing for the AI to flatter or smooth over here. You just stock your exits so the loop stops when tests pass, stops if it hits, say, 15 attempts, or stops if it gets stuck and the last 3 attempts didn't change which tests are failing. Boom, done. Once you actually trust the loop, because you've watched it perform correctly, you move it into a script. It becomes a nightly cron job. Suddenly, the phrase "runs while you sleep" stops being a marketing slogan and becomes your reality. Imagine your mornings shifting from manual coding and fixing yesterday's breakages to simply reviewing finished, summarized work while you sip your morning coffee. Your loop literally becomes your infrastructure. Let's look at Section 4, Avoiding Common Loop Traps. Why Beginners Fail. Okay, before you go off automating your entire workflow, we need to be incredibly careful to avoid these specific pitfalls. The biggest temptation by far? Automating a process before you even understand it. If you haven't manually mapped out the steps first, you're just going to get really fast, confident garbage. Likewise, using weak self-referential verifiers or letting the loop run wild without hard termination logic, skipping that persistent state memory we talked about, or removing the human from those irreversible actions, do any of these and you turn a helpful tool into a very expensive, reckless liability. Now, as you scale your systems up, you'll need to deliberately choose between an exploratory open loop and a bounded, predictable closed loop. A closed loop repeats a bounded task toward a fixed target. It's safe and it's cheap. An open loop, on the other hand, explores novel approaches. It risks more of your budget, but potentially gives you way more upside. You've really got to match your verifier to the choice you make, balancing your required novelty against your budget. And speaking of budget, cost management is absolutely vital. Think about it. Loops make 10 to 100 times more model calls than single typed prompts. Doing this the naive way? It will bankrupt you. Seriously. You must be disciplined. Route the simple tasks like basic classification to the fastest, cheapest models out there. Save those expensive frontier models only for the final, really difficult reviews. And finally, Section 5, your ultimate edge, taste, the final mastery. We've covered the mechanical steps, but the truth waiting at the very end of this roadmap is that the ultimate skill required for all of this isn't technical at all. It's deeply human. In a loop engineering world, your domain expertise does not become obsolete. It radically transforms. It becomes what we call taste. Taste is the reward function the whole system optimizes against, encoded as a strict check based entirely on your expert judgment. A senior engineer just knows what correct code looks like. A great editor knows what strong writing looks like. Your judgment becomes the single most leveraged thing you own. Because here's the reality check. The loop doesn't have taste. You supply it. The loop just enforces it tirelessly. What this means is that the quality of your automated output is entirely capped by your ability to articulate what correct and excellent actually mean in a way a machine can verify. If you can't tell good output from mediocre output, well, your loop will just happily produce mediocre work at a terrifyingly incredible scale. But this brings us to a highly reassuring point. The people who learn to design loops will not be replaced by more capable AI models. No, they're going to direct them. As models get better and better at long tasks, the person who can point those models at a goal and effectively encode their expert judgment as a strict verifier, that person gets exponentially more valuable, not less. The movement that named all of this is incredibly new. That means the window to get ahead of the curve is wide open right now, today, before it just becomes the obvious default for everyone else. So I'll leave you with this final thought to ponder. Will you keep typing prompts and waiting for answers, remaining the bottleneck?
Or will you design the loop that does the waiting for you? Start building your systems today.